Ivana, let's tell the class about ocean acidification.
Alright, seawater chemistry is changing rapidly in the world's oceans. Ever since the Industrial Revolution, a new onslaught of fossil fuel burning has taken place. Global climate has been highly impacted by anthropogenic sources releasing carbon dioxide into the atmosphere.
Anthropogenic sources worldwide are responsible for emitting about 24 gigatons of CO2 annually, on top of what is already released by natural processes such as respiration and geology.
So, where does all of this CO2 go?
It is absorbed by what we refer to as sinks. Approximately 50% of all CO2 goes directly into the atmosphere, while 25% is absorbed on land by fresh water and plants. Finally, 25% dissolves into the ocean.
Unfortunately, there is a common misconception that this is a good place for all our excess carbon to go. Many people believe that as long as CO2 no longer resides in the atmosphere, we are safe from its harmful effects. However, this is not the case. CO2 being absorbed by the oceans around the world has extremely detrimental effects.
Ocean acidification, otherwise referred to as OA, is the term that describes the chemical changes to the ocean's water as a result of CO2 absorption. In order to understand how this process works, we first need to learn some basic chemistry to help us out.
pH is the term that describes the concentration of hydrogen plus ions in a solution. The pH scale ranges from 0 to 14, with the lower end of the scale being considered acidic and the higher end being basic.
Normal water is rated about 7 on the pH scale, while the ocean water is normally slightly more basic at 8.2. With the influx of CO2 entering the oceans, this value has dropped down to 8.1, a decrease by 0.1 pH units.
This represents a 25% increase in acidity in the last 200 years. It has been projected that by the year 2094, ocean pH will be down to 7.8. So, how does this process work, and why does the ocean serve as a sink to CO2? Well, H2O readily absorbs CO2, creating carbonic acid, which, as you can imagine, is bad. As more carbonic acid is created, more hydrogen ions are released, which then impacts carbonate and bicarbonate. The end result is a reduced saturation of calcium carbonate, specifically in shallow waters globally up to about 10 meters, where a vast majority of ocean life is found.
All of this seems relatively harmless, right?
Wrong!
Okay, so not quite so harmless. So the ocean's chemistry is incredibly delicate, and even the slightest change in the components can affect all life underwater. The first victims of ocean acidification are organisms that depend upon the minerals present in the water to form their structures.
These especially are organisms that build their shells and skeletons from calcium carbonate, such as corals, which suffer from coral bleaching, oysters, clams, mussels, snails, pteropods, phytoplankton, and zooplankton, the tiny plants and animals that form the base of the marine food web.
So it's not only the little guys that suffer?
Actually, no, they aren't. It is not only those directly affected by the ocean's pH that will suffer. Other organisms will be affected indirectly because their food sources and habitats may become very scarce. If it isn't enough that organisms are slowly losing their basic functions and properties, just remember how much human life depends on the ocean and everything that comes from it.
Exactly! Without a healthy marine environment, not only will an important food source become very threatened and limited, but also entire economies that depend on what the seas offer could collapse.
So, to sum it all up, ocean acidification is a real problem that truly has very substantial consequences. There is no fast and easy answer to this issue, but one thing is for sure, it has to begin with us. Humans are largely the cause, and therefore all of us should be part of the solution.